Welcome to the session, the architecture of internet censorship and filtering systems. Suppose Ananya, an employee or student, wants to access information on the internet. Throughout the presentation, we follow her request and observe how different filtering systems inspect, block, slow down, or allow her traffic. Right? So imagine Ananya opens her laptop and types www.youtube.com in her browser. She expects the video to open immediately. But between her device and the global internet, there are many invisible checkpoints pointing to the user device, global internet, invisible checkpoints. And this entire session is about understanding those invisible checkpoints. Now, meanwhile, do you think your device directly talks to the Google service? Actually, many systems may inspect or modify that communication, right? So you could see a system level breakdown of DNS blocking, IP filtering, DPI, and the invisible checkpoints between you and the web. Right? That is between the user device and the global internet. Now, the normal flow versus the intervention. Now, coming to the normal flow, it could be the user browser to the destination server. Ideally, communication should be direct in the normal flow. That is, from the user browser to the destination server. But suppose Ananya is in a college campus or corporate office. The organization may want to inspect the traffic. Here, filtering systems become interceptors, inspectors, decision makers, and all. Right? So now let's see where these filtering systems are actually used. So in the order, coming to the enterprise security, companies block risky websites to protect employees. That is, you could see scanning for malware and phishing. Next comes school networks. Schools may block gaming and social media during class hours. Of course, asking students to focus on the classes, right? So blocking gaming and social media during class hours. So here you could see filtering social media and gaming. And then comes government control. Some countries restrict access to the specific information. That is, enforcing information and control. And next comes parental controls or malware protection. Organizations scan for phishing and malicious websites. That is, blocking adult content. Although the reasons differ, the technology behind filtering remains almost identical. Have you ever seen websites blocked in your college Wi-Fi? Just try to relate to your college things. The first checkpoint begins even before visiting a website. The DNS blocking corrupts the network phone book. And let's try to understand. The internet works like a city, having domains like google.com, youtube.com, and they are all the names. IP addresses are actual house numbers. Now, understanding through the story, suppose Ananya enters youtube.com. So there, the step 1, browser asks DNS, what is the YouTube IP address? Right? It has to understand first of all what is YouTube's IP address. And then filtering system intercepts. It either returns wrong IP, gives no answer, or drops the request. The result, website never opens. So it is somewhat like you ask someone for a friend's address and they intentionally give you the wrong house number, right? So what if DNS succeeds and website IP is known? Now let's try to understand this through the page here. The request, user, request, domain resolution, and then the intercept. DNS resolver checks policy database, and then poison. System returns a fake IP or drops the request, preventing connection. So again, repeating the question: what if DNS succeeds and a website IP is known? So coming to the IP and URL filters acts as the network bouncer. Now, Ananya already knows the destination, for suppose. Now, there are two possibilities. One, IP blocking. The security system blocks the entire building. For example, 142.250.x.x. That is one of the address. So it is getting blocked or being blocked. Here, entire service becomes inaccessible. You could try to relate a security guard saying nobody can enter this building, right? Trying to block, right? And next comes the URL filtering, that is keyword filtering also. Instead of blocking the entire building, only specific rooms are blocked. Try to relate. Earlier in the IP blocking, it was like security guard saying nobody can enter this building. But in this, instead of blocking the entire building, only specific rooms are blocked. For example, only youtube.com is allowed and youtube.com/gaming is actually blocked. That is, trying to access the gaming content on the YouTube. Now try to relate. You may enter the mall but not the movie theater. But modern applications hide information inside packets. And how do we inspect that? Right. You could also try to understand through the slide here. That is, in the IP blocking, it drops the entire destination coordinate, blunt and absolute. But into the URL filtering, it selectively drops specific paths or payloads within a clean destination. So now, repeating the question again, modern applications hide information inside packets. How do we inspect that? So yes, coming to the deep packet inspection, that is DPI, X-rays the cargo. Pointing to the traditional firewall versus DPI. Suppose traditional firewall checks address, port and protocol. Then DPI checks actual contents, applications, behaviors. Right. So trying to understand with the story, suppose Ananya downloads a file and firewall sees the file is coming. That is, the file is entering. Then DPI asks, what is inside the file? It is something like an airport X-ray scanner, right? Right? So outside it is like a gift box and inside it includes malware. So the key statement is that DPI shifts filtering from root inspection to the content inspection. You could see in the image the traditional firewall as like someone checking the package, whatever is received, whether it is actually including malware or not. And then the other side, X-ray reveals payloads, the DPI system. So DPI shifts filtering from simple routing rules to the deep content analysis, ignoring ports to block underlying application behavior. But modern websites use HTTPS encryption. And now let's try to understand the HTTPS challenge logs the cargo in a vault. How does it happen? Now, without directly entering into the HTTPS, let's try to begin with the HTTP, right? The HTTP traffic, which is unencrypted. It is visible with URLs, content, payload. But coming to HTTPS, which is encrypted, it is visible with the destination IP, the domain, the timing, and all. The HTTPS places the entire conversation inside a locked vault. You could see the vault how it looks in our real life, right? Not in the technical world, right? So try to understand with the story. Earlier, security staff could read every letter. Now they only see who sent it, where it goes, but cannot read the actual message. Can you read a sealed envelope without opening it? No, exactly. But even encrypted communication reveals small clues, not entirely, but small clues. So moving forward with the SNI filtering scans the label before the vault locks. Suppose before encryption begins, browser and server exchange some information. The one important information is regarding the server name indication, that is the SNI. Understanding with the story, before locking a parcel, the shipping label is still visible, and filtering systems quickly inspect this label. For example, Netflix.com system sees label and blocks connection before encryption starts. Now this is somewhere like courier company rejecting the parcel after reading destination label, right? So you could see the approach, the handshake, the decision. Unwanted things are rejected and wanted things are accepted. So during the TLS handshake, metadata must be exchanged in plain text. Filtering systems target this brief window of visibility. Some organizations need even much more control. So moving to the web proxies force traffic through an inspection hub. Now, pointing to the proxy architecture. Instead of allowing direct internet access, organizations introduce a middleman, right? So here, relating with the story, Ananya requests YouTube, and the flow becomes Ananya to the proxy to the internet. Now, the proxy includes logs activity, categorizes websites, catches responses, right? So it is somewhere like a company receptionist. Nobody directly meets the CEO. Everyone goes through the reception, right? So you can understand through the image here, the exit track 1, educational email, the exit track 2, social media, the exit track 3, the catchy data. Proxies act as invisible middlemen, logging requests, categorizing domains, and catching responses locally, right? So continuous inspection introduces performance challenges. Now moving to the engineering cost, bottlenecks, and shaping, right? Inspection consumes resources. True, right? Inspection requires resources. Without it, it may not be completely possible. So, the resources here could be termed as latency, memory, processing, and all. Understanding with the story, imagine airport security. Checking every passenger thoroughly causes queues. And similarly, heavy DPI causes delay, slow browsing, processing overhead, and all. Rather than blocking YouTube, organizations intentionally slow it down, right? So, have you ever experienced extremely slow YouTube on campus Wi-Fi? Right? Users naturally search for ways to bypass restrictions, and it is absolutely true. So, the collateral damage in the IP sharing era. Now, there are two major challenges, the CDN problem and the VPN bypass. Coming to the CDN problem, Thousands of websites may share one IP, one single IP. Blocking one IP may accidentally block many legitimate websites. It is something like closing an entire apartment building because one resident violated rules. And now, coming to VPN bypass, moving with the story, Ananya installs VPN. Traffic becomes encrypted, and local filters cannot easily determine final destination. Now, here you can relate that instead of writing destination openly, courier sends everything through a trusted intermediary, right? The transition. Therefore, modern systems are becoming more intelligent. You could also try to understand this through the slide presented, right? The CDN problem, IP ban, shared CDN IP and all. But the VPN bypass, CDNs make IP bans destructive, while VPNs encrypt the destination to blind local filters. Now, getting to the modern systems, shift to the pattern recognition. Compare legacy and modern. That is the static rules and AI behavior analysis. Under the legacy, the static rules, for example, block facebook.com. But in the modern, AI analyzes malware patterns, bot behavior, suspicious activities. Understanding with the story, the old security guard follows fixed instructions, right? The security guard here follows fixed instructions that were actually delivered earlier. Now, the modern security guard learns suspicious behavior, like what is going wrong or how it has to be treated, right? For example, this employee normally works in Hyderabad. Why is login suddenly coming from Russia? Right? In the same way. So many misconceptions exist about filtering systems. So, filtering relies on AI models to preemptively identify command and control servers and dynamic threats before content renders, right? So, further, common misconceptions about network control. Take each misconception separately. Now, the first one, incognito mode. Who thinks incognito hides activity from college Wi-Fi? Incognito only clears local history. Network still sees traffic, right? Now, slow website means blocking, right? Yes or no? It's actually completely no. It could simply be congestion or bandwidth stripping, right? Then the HTTPS prevents filtering. Yes or no? It's actually no, and a complete no. Metadata remains visible, right? So you could also try to understand through the comparison, through the myths and reality. The first one again, I repeat, incognito mode hides my traffic from the school or corporate network, while the reality, incognito only clears local history. The network proxy still logs every domain requested. The next point, if a site loads slowly, it's being blocked. And that is actually completely false. In reality, blocking abruptly drops the connection. Throttling intentionally slows it down to manage bandwidth. The other point, HTTPS prevents all network filtering. Again, which is completely false. In the reality, HTTPS encrypts the payload, but SNI and destination IPs remain exposed for filtering. Moving ahead, the diagnostics of network control, system comparison. Let's compare all technologies we have discussed and walk row by row. Right. Under technology, the first one, DNS filter or DNS block. It is regarding the domain name, right? So it lies into the network layer of application. What it sees, the domain names, and its processing overhead is very low, and its bypass difficulty is very easy. It could change the DNS. Coming to IP filter, it sees a destination, that is the IP addresses, and it lies in the network layer. Its processing overhead is very low, while its bypass difficulty is moderate. And the proxy, that is web proxy, right? It lies in the application layer, and what it sees, URLs, categories, and all. And its processing overhead is very high, and its bypass difficulty is very hard also. Now, coming to deep packet inspection, it is lying over all layers, and what it sees, payloads and behavior, and the processing overhead is very high, and the bypass difficulty is very high. So more visibility, more processing overhead, and then let's summarize everything using simple mental models. The ultimate mental models for system design. And this is your recap slide, right? The DNS filter, acting as a phone book controller in the real life. That is, it stops the domain name from resolving to an IP. Then the firewall, it blocks specific IP coordinates, and the web proxy, it manages logs and categorizes centrally. It could be something like a reception desk in real life. And coming to DPI, it inspects contents and behavior, not just headers. Now here, you could term it as a X-ray scanner in real life. Now coming to VPN, it encrypts the transit, rendering local filters blind. Now here, it could be termed as privacy tunnel.